So if you look at this, today we are doing transformations using tables. So if you look at this table, I'm going to transform it. Now if you notice, it says f of x equals x squared. So the x squared is just the parent function. It's a quadratic parent function. Um, so negative 3 squared, or negative 3 times negative 3 is a positive 9. And you could go through and that's the rest of that. So this is a 10 by 10 grid, and I just put the y-axis in the middle so that I can plot both sides of this parabola. So negative 1, negative 2, negative 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 2, negative 1, negative 2, 1, 2, 3, 4, negative 1, 1, 0, 0. And remember, it's symmetric, so I really could just go 1, 1, 2, 1, 2, 3, 4. You know it's going to be symmetric, so 3, positive 9. So that would be my parent function. So that is my parent function. Now, what it means by transforming using tables. You're not actually going to see the graph. They're going to give you a table. More than likely, it's only going to have 4 points. On your assignment, it's only going to have 4 points. But I wanted you to just see that this is the parent function. So what you're going to be doing, and if you look at this screen on Agile Mind, so notice this is the parent function, and then this is going to be the transformation of that parent function. So if I move it, let's just move it 2 to the right. Oops. Notice the values. It didn't shift the y values, it only moved these right here. So negative 1, 0, 1, 2, 3, 4, 5. Notice it says g of x is x plus 2. So the f of x, so you're taking the original function and you're just adding 2 to the x value. Let's go the other direction just to see. So notice every single one of them from negative 3 to negative 5 got smaller. 0 to negative 2, they subtracted 2. And you could go this, if I go back this direction, notice each time it got 2 bigger. From 0 to 2, it got 2 bigger. 1 to 3 got 2 bigger. You could look at these negative values, but usually what happens in negative values is people get the signs messed up. So notice that each time you just took your x value and you added 2. Okay, so let's go ahead and write that out. So we're going to do a positive 2. So I'm going to take each of these points and shift them over 2. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So my new parabola is shifted to the right too. So I would write my table as x and then if you look, it's g x plus 2. So my h values didn't change. So if you look at this point right here, so we'll just call this point A, this is point A, this is point A, and we actually call it A prime because it's the new one. But so from here to here, this point is now negative 1, 9. This point is 0, 4. This point is positive 1, 1. This point is 2, 0. This point is 3, 1. This is 4, 1, 2, 3, 4. And then 5, Now, if you notice from here to here, the only thing that changed is the x value added to. So 3 plus 2 is 5, 2 plus 2 is 4, 1 plus 2 is 3, 0 plus 2 is 2, negative 1 plus 2 is 1, negative 2 plus 2 is 0, negative 3 plus 2 is negative 1. It did not shift up or down any, so you did not see these values. So this is A prime. So A and A prime are just these points over here. Notice it moved right too. So if you look, these values moved right too. And that's exactly what ours looks like. I didn't want that screen. I wanted this screen. So it's talking about A and then how H prime changes. So A prime is just a shift of whatever H value. Okay? Now, let's do a shift of if it's not just H, if it is a K value. So if I'm going to give you a table, so X, so I went ahead and paused it just to make sure, or to write down this table. So the first point is 1, 5, 2, 8, 3, 13, 4, 20. So if I tell you I want you to create the table of X and then f of X plus 2. Now notice if it's not inside of the parentheses, so it's not an H value, it's a K value. So the only thing that will change is the Y, because remember, K value shifts vertically. So the X values will stay exactly the same. So 1, 2, 3, 4. And then the K values are going to shift it up or down. Now, since it's a plus 2, you would shift it up. So that would mean from a 5, if I had a point at 1, 5, and I want to shift it up to, it would still be left or right however much. It would just shift up. So 5 plus 2 is 7, 8 plus 2 is 10, 13 plus 2 is 15, and 20 plus 2 is 22. I'm going to go ahead and just sketch those points. Again, on your assignment, it's going to call it A, B, C, D, and then it would be A prime, B prime, C prime, D prime. Remember that prime from geometry? It just means the transformed point. So if I sketch this graph real quick, and it's going, I'm going to have to go by 2's just because of it being such a large number. So if I'm at 1, let's do 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and 22 will be up there. We're just going to leave it. So I'm going to go 1 and then up to 7, and I'll do orange first. So 1, 7, 2, 8, 3, 13, 4, 20. So that's the original. Now if I want to do shifted up to, since I had to scale it a little bit weird, it would be up 1, up 2, up 1, up 2, up 1, up 2, up 1, up 2. So it would be up there. So if you notice, this point is at 11, that point's at 10, that point's at 15, that point's at 22. So this is A prime, and B prime, C prime, D prime. Okay, so those are your values. Notice only the y values changed in the table. If you have both, then you would have to change the y values based on the k value and the x values based on the h value. Now, the last thing that you're going to see is if you are given two tables. So if you're given two tables, it's going to ask you for the equation. So x f of x and then x g of x or whatever of x. So let's say I have 1, 3, 5, and I have 15, 14, 13, and then my transformed is 0, 2, 4, and then I have, let's do 12, 11, 10. So if you look at those values, you need to find out how much the x changed first. So if you look from 1 to 0, it went down 1. From 3 to 2 went down 1. From 5 to 4 went down 1. You could also take 4 and subtract 5. So 4 minus 5 is -1. You always want to take the second and subtract the first. 2 minus 3 is -1. So the x values went down 1. Okay, and then if you look at the y values, and I'll just do it this way, from 15 to 12, or you could subtract 12 minus 15 is -3. 11 minus 14 is -3. And 10 minus 13 is -3. So the y values went down 3. So for your equation, you would write it as g of x is equal to f x. Now, inside of the parentheses is the h values. So remember the h values are used when x changed, and k value are used, k values are used when y changed. Because think about it, the x-axis is the horizontal axis, the y-axis is the vertical. So on this, g of x is equal to f of x. Now it went -1 or down 1 each time. It shifted back 1 or left 1. And then the y values went down 3. So this is probably the hardest part about transformations. That's why we did all of the other stuff first. If you look at the table, shift it. Now, if you cannot, I very much suggest graphing these on paper first. So graph both of them and then talk about the transformation and then write it in function notation. Remember, we write it in function notation because we're just saying from the original function to the new one. You don't want to have to write the equation for both of those. It's better to just say g of x is equal to f of x minus 1 minus 3, and just to give how the points changed. Remember, if you're stuck on any of that, ask me. If you graph those, it would have moved. You'll have to see how you would see how the two graphs shifted. So that's why I very much suggest using graphing paper on these if you get stuck.